Thank you again for joining us for the Tech Data Cyber Range Lunch and Learn. Hopefully you saw John's portion in which he went through our presentation on the network mapper, also known as Nmap. This is course or lesson number 4. Again, a brief overview or to summarize what John went over. Network Mapper, Nmap, is a free and open source network scanner. It's used to discover hosts and services on a computer network by sending packets and analyzing the responses. It provides several features for probing computer networks, including host discovery, service and operating system detection. And it also has enumeration scripts from the Nmap scripting engine. And these specialized scripts help reveal additional information from host responses that we scan. So today, or for this video rather, we'll be going through those commands in the terminal so you can see what it looks like in addition to the screenshots that you saw. I encourage you, if you did not watch that first portion of the video, to go back and watch it, because John brings up some information that I'm not going to because it will just be redundant. So the first thing we're going to do is we're going to use the default Nmap scan. Nmap as an organization provides us this website, scanme.nmap.org. Scanme.nmap.org provides us with a way in which we can test our different Nmap commands. So to run the default scan, you just simply type Nmap and then the target domain or IP address that you would like to scan. This scan will only cover the 1,000 most common ports, and this performs a default TCP SYN scan, which usually in Nmap is done like that with attack lowercase s, uppercase s. So we see from the output of our default scan, just nmap scanme.nmap.org, there are a couple of different ports that are open, and there is a small amount of fingerprinting that has happened against those ports, which have shown us the service. Also lets us know the state, whether it is open, filtered, or closed. Familiarizing yourself with the state is outside of the scope of this demonstration. It is something you can find within the Nmap manual page. If you've seen one of our videos in the past, you can always just run man Nmap, and then you can search for the term you want to know and then see where it's outlined in the documentation, right? There are also other ways, again, another item outside of the scope for the demonstration, but something that could help you as you go on your Nmap exploration and using the tool, is you can filter your commands based upon the types of states. So if you don't want to see things that are filtered or closed, you can eliminate them from the output and what is reflected to you in your terminal. So just here we see TCP 22 SSH is open. We see 80s open. Some other nping echo and elite command or elite services are open as well. Something that we can do further is, let's say we wanted to scan for a range of ports. So we just ran our default. You use Nmap as the command, but then you use your -P option, which stands for port, and you specify the number of ports that you would like to scan. So let's say we just want to scan a port range of 1 through 80. And we say, okay, we're going to scan the same site, scanme, nmap.org, and we go ahead and do that. What you'll see here is, because I specified port 1 through 80, my output only gives me ports within that range, whereas the scan we issued before gives me more port numbers beyond our stopping point of 80. So this is a way you can narrow down your range if you're scanning or you're doing what we call reconnaissance or information gathering about a target, and you know it is just a web server and you're familiar with what the common ports are of a web server, you, instead of being very verbose in your scan, can limit to say, I only want to scan common ports for a web server. So we know it's running HTTP. Great. So we could just say nmap p80 scan me, not nmap.org, and it will only look for port 80. So I'm going to go ahead and clear out the terminal there. That was an example of scanning a specific port. We can give you another one here. I'll just say scan, let's say nmap. We know that port 22 is open, so let's just say scan port 22, scan me nmap.org. And there you go. That is scanning with specified ports. Now, one of the things commonly forgot about, at least from the offensive side of security, and in some ways defensive, is not only do we have TCP ports, but we also have UDP. To understand the difference of TCP and UDP, again, I encourage you to go back and rewatch John's portion of this module or this Lunch and Learn, where he explains what is the difference between TCP and UDP. I won't go into that so much here, but just know different services require different port types, whether it be TCP or UDP. To do a UDP scan in Nmap, you use a -SU, the -SU option. Again, I cannot emphasize this enough. UDP reconnaissance or UDP scanning is just as important an enumeration step as TCP. Because UDP does not have a complete handshake, we talk about how TCP has a three-way handshake. UDP does not have that completion of a transmission. Your scan could take longer. So we'll go ahead and run it. I'll go ahead and elevate my privileges here to run the UDP scan. And the likelihood of why we have to run it as sudo is because it has to open up some additional sockets to do the standard UDP scanning. Here we see that port 123 or 123 is open for the network time protocol. So that's an example of UDP scanning. Now, this is all good. This is all great, but it doesn't tell us the specifics of the versions running on these services. So every service has a version similar to how you have operating system versions. You had Windows XP, Windows 7, Windows 8.1, and now Windows 10. Versions are somewhat the same. It's either revisions in the software or the application that needs a service to talk on the network. And that is what can tell you whether or not those services are up to date or behind. So what we're pivoting into here, or where we're going rather, is with version scanning, you can enumerate and fingerprint the applications running on the open ports that are found. So we'll say nmap sv, and again, it's going to run a default. So it's going to do that top 1,000 ports. We'll say scan me nmap.org. It's going to run against the top 1,000. And then in addition to that, it's going to do some enumeration and fingerprinting. Something you can do, if you double tap enter, it'll provide you with the scan timing. So how much of it is completed, what is the time remaining, when was it issued. Something I'll note as well, and something I like about Nmap, is you can increase your verbosity level, or the verboseness of the output to your terminal. And that helps so that you don't have to, press enter a couple of times to see where you're at. But from the output here, we see that SSH is running as OpenSSH 661. Okay, The other ports didn't provide us the specifics of their version. Looks like Nmap here with the question mark couldn't determine whether it was using SSL or straight HTTP. John talked about as an example, port 80 is typically for insecure web traffic, whereas HTTPS uses SSL or some version of TLS or what have you over 443 to make your web connections secure. So, like I said, I wanted to show you using verbose. You can use one, however many V's you use, increase the verbosity. I'll point you to the man page for the total number of V's that you can use. But I, as a matter of habit, just use 3 V's. And let's include our service version scan. And as you can see, instead of having to press enter, it's outputting what's going on and happening. So I can ensure my scan is running. We're going to go ahead and let that just finish up, or I can actually just cancel it here since we already know what the output looks like. Next, what we want to hit on is doing a OS or operating system scan. This is where Nmap tries to fingerprint, and if it can't fingerprint, it guesses what operating system is running on our target host. I would like to note that that is a O as an Oscar, an uppercase O as an Oscar, and not a 0. Let me make sure my address is right. And as you can see again, this OS scan requires root level privileges, so we'll run it as sudo. And here we have the guess of, okay, there's a high chance it's some version or variant of Linux. Gives you some other information about maybe it's a Linksys embedded or Google Android or what have you. Their aggressive OS scan said again, okay, this is Linux. So we could assume, I would say that's probably not the best thing to do here, given the fact that there are these MSRPC and Microsoft DS ports that are showing up filtered. It might not be Linux. It could actually be a Windows server. But that's where you would have to go further down the road of fingerprinting to fully figure it out. So one way, and as a side note, you could do that is specifically try and enumerate what's running on the HTTP server. Because, you know, if you're running a Apache or Nginx, those are heavily used on GNU Linux or Unix-based systems. Apache sometimes is actually run on Windows, depending, but most predominantly people will run IIS, and that's a specific web application for Windows and hosting websites. So if we wanted to put it all together, how would we do so? Well, we say Nmap, we tell it what level of verbosity we want to do. The -p- is a run all ports. The -sv is that service version enumeration. The SC says run common scripts out of the NSC. And then PN says treat the host as up. We've scanned it several times, so we know it's up. We don't have to send it a ping before. The -A adds the ability to do OS detection and a trace route for us. We then can say, okay, here's my target, scan me, nmap.org, if I could type. And then we say, okay, output my scan as my scan.xml. Now, there are several ways you can output Nmap scans. You can put it into a greppable format or just to a raw text file. It depends on what you prefer and what you like to do. In one of our later modules or one of our lunch and learns, we can talk about how you could convert this XML file into a nice little HTML file. which you can then view as a pseudo Nmap report. So we'll go ahead and let that run. Something I'd like to mention as this is taking a while, you see these max successful trino increase. These send delays can be either because there is a firewall or some type of security appliance in front of the host we're targeting. So we can change the timing of our scan. And I think this is beneficial rather than you just watching the output of this. If you go to man and map, because the output of the scan is just going to be the same anyways. You see here, they're using as a representative example this TAC T4. That is the timing. So it's saying, okay, to use a timing level of 4. The max timing level you can use is 5, and the lowest is 1. So let me see timing. Let's see. This may be better. Max retries. Timeout. So here you have the timing. Set a timing template, right? Paranoid, sneaky, polite, normal, aggressive. Just see 0 through 5 is the level at which you want to scan. So normal is a T3. Anyways, that is the gist of Nmap. In John's presentation, he provided you with some resources on Nmap. You can look at nmap.org for their book, or you can just use the man page. So with that, we thank you for watching this Lunch and Learn demonstration for the 4th video in our series on Network Mapper Nmap. Have fun and happy hacking.